Welcome to the Explainer. Today, we are doing something absolutely incredible. We're diving headfirst into the world of Python. Now, if you're looking at the screen right now and thinking, wait, I don't know the first thing about coding, take a deep breath. You are in the exact right place. We're going to build your knowledge from the absolute ground up, and you need zero prior coding experience to follow along. By the end of this Explainer, you won't just understand what Python is, you will have written your very own working program.
Here's our roadmap for the next few minutes. We'll start with Welcome to Python, then write your first Python program. After that, we'll dive into variables, the magic boxes, move on to exploring data types, and finish up with a hands-on mini project and quiz.
All right, let's jump right into part one. Welcome to Python.
Python is just incredibly versatile. It's not some exclusive language just for hardcore software engineers. It's a tool for absolutely everybody. We're talking about empowering you to build complex AI, analyze huge data sets, or create web apps. But honestly, my personal favorite is automating repetitive tasks. If you're sick and tired of manually renaming hundreds of files at work or updating spreadsheets, you can actually build a tiny Python script to do the whole shebang for you in seconds.
And here is the absolute best part. No coding experience required. Python was purposefully designed back in the 90s for readability. The syntax, which is basically just the grammar rules for the code, looks a whole lot like regular everyday English. That makes it the absolute perfect starting point for your programming journey. You spend way less time worrying about complicated computer jargon and way more time actually solving problems.
So, let's get our hands dirty. Section 2, your first Python program. Using an editor on your computer, like VS Code, you literally just type the word print, open a parentheses, drop in a single quote, write hello world, close the quote, and close the parentheses. Notice how clean that looks? You are quite literally telling the computer, hey, print this text to my screen. And when you run this simple line of code, boom, instant output. You see hello world pop right up on your screen. Think about that for a second. You have just successfully communicated your very first instruction to a machine. The computer read your command, understood it completely, and executed it perfectly. Let's break down the anatomy of what you just did. The text inside those parentheses, the hello world part, is what we call an argument. When you use the print function, you have to hand it an argument so it knows what to actually display. The quotes are just there to tell Python, hey, this is text, so the quotes themselves don't actually show up on your screen.
Okay, moving right along to Section 3, Variables, the magic boxes.
Instead of getting bogged down in complex technical jargon, I want you to simply picture a variable as a little cardboard box sitting in the computer's memory. You take a box, you slap a name tag on it, in this case, let's label it spam, and then you can safely store a value inside of it, like the number 42. In Python, you just type spam equals 42. And just like that, you securely pack the number 42 away to use later in your program.
But here's a crucial thing to remember. This brilliantly illustrates what happens when you overwrite a variable. Let's say you decide you don't want 42 in your box anymore. If you assign the word goodbye into that exact same spam box, the old value is thrown right out. A single box can only hold one thing at a time, so the computer permanently forgets the old value. So let's trace the logic here together. If you assign goodbye to the variable named spam, and then in the very next line of code you ask Python to print what's inside spam, it's going to confidently output goodbye. The program looks at the label, opens the box, sees what's currently inside, and hands that exact value right back to you.
Section 4, Exploring Data Types. Now that we have these magic boxes, what kind of distinct things can we actually put inside them? Well, Python has several basic categories for data, and every single value you ever use belongs to one of these types. Here are the big four. First up, strings, which is just text enclosed in quotes. Second, integers, which are whole numbers like -2 or 30. Third, floats, which are numbers with a decimal point, like 3.14. And finally, Booleans, which evaluate to either true or false.
The really crucial point is seeing how this looks in practice. Let's imagine we're making a profile for a pet. Leo is surrounded by quotes, so it's a string. 7 is a whole number, so it's an integer. 5.6 has a decimal, so it's a floating point number, or a float. And finally, true is a Boolean. We've just assigned 4 entirely different data types to 4 differently labeled boxes.
I want to pause on Booleans for a quick second because they're kind of unique. The Boolean data type only has 2 possible values, true and false. Notice how they lack quotes? If you put quotes around true, Python just thinks it's a regular text string. Also, they always start with the capital letter. They are the ultimate way for a computer to represent simple truth values, literally just like a light switch being on or off.
All right, let's put all of this together. Section 5, Mini Project and Quiz.
Here's your challenge. We're going to build a simple profile. Step 1. Create 2 variables, one for a name and one for an age, and assign values to them. Step 2. Use that print function we learned earlier to display what's inside those variables right onto the screen.
Seriously, I highly encourage you to pause the explainer right here, open up your editor, and try typing this code out yourself. Assign the string Leo to the variable name, assign the integer 7 to the variable age, then call print on name and print on age. Go ahead, give it a try.
Welcome back. If you ran it successfully, your terminal should look a lot like a mini ID card printing out Leo and 7 on separate lines. Think about what you just accomplished. You stored different data types in variables and successfully retrieved them. That right there is the core foundation of all software development. Before we wrap up today, let's try a super quick quiz. I'm going to ask you to pause the explainer for 5 seconds, and guess what happens if we attempt to add a text string to an integer? What happens if you literally type quote 42 and quote +3 into Python? Think about what you just learned about data types, and the answer is a syntax error. Python literally stops in its tracks and displays an error message. Why? Because Python strictly separates text strings from numerical integers. As we saw, the quotes around 42 make it text, not a number. Python is incredibly smart, so it prevents you from accidentally trying to do math with words. You can't add or multiply the word apple by the number 3, right? And that brings us to an awesome final thought. Solving programming problems on your own is way easier than you might think. Getting errors is totally normal. It's exactly how we learn. So here's your homework. Practice today's examples at least 3 times. Create a favorite_food variable, an age variable, and a city variable, and print them all out. The absolute best way to learn programming is by writing code yourself. But as you look at those simple printed words and numbers on your screen, ask yourself, how do these tiny basic building blocks combine to take in data from users and build truly interactive programs? We are going to unpack that exact mystery next time. See you in Lesson 2.